Good day, everyone. We are the Group 5 presenter in History of Mathematics, and the assigned topic that was given to us is entitled Mathematics in the 18th Century. So, let's begin. The 18th Century Mathematics. This period was mostly overtaken by the works of Newton and Leibniz, and they also applied their ideas on calculus to solving a variety of problems in physics, astronomy, and engineering. Dominated by mathematicians from France despite the popularity of Euler and Bernoulli. During this period, a very known family named Bernoulli's family in Basel of Switzerland was also dominated, they also dominated during this 18th century mathematics, but still the domination of the French mathematicians still prevailed. And one of those mathematicians is Pierre-Simon Laplace. Most developments were attributed to the three L's, namely Joseph Lagrange, Pierre-Simon Laplace, and Adrien Marie Legendre. So let's meet the mathematicians in the 18th century. So here are some of the mathematicians in the 18th century.
And one of that is Joseph Louis Lagrange. Well, Joseph Louis Lagrange was born known as Joseph Luigi Lagrange or Joseph Lodovico de Lagrange Tournier. He was an Italian mathematician and astronomer, and he was later naturalized French. He made significant contributions to the fields of analysis, number theory, in both classical and celestial mechanics. So he contributed to differential equations and number theory. He was also credited with originating the theory of groups. In his four-square theorem, where any natural number can be represented as the sum of four squares. And he also had his Lagrange's mean value theorem, wherein given a section is smooth differentiable curve, there is at least one point on that section at which the derivative of the curve is equal to the mean derivative of the section. So, on 1810, Lagrange commenced a thorough revision of the mechanic analytic, but he was able to complete only about two-thirds of it before his death at Paris in 1813. In 128 Rue de Faubourg Saint-Honor, Napoleon honored him with the Grand Croix of the Order Impériale de la Réunion just 2 days before he died. So he was buried that same year in the Pantheon in Paris. So the inscription on his tomb reads in translation: Joseph Louis Lagrange, Senator, Count of the Empire, Grand Officer of the Legion of Honor, Grand Cross of the Imperial Order of the Reunion, member of the Institute in the Bureau of Longitude, born in Turin on 25th of January 1736, and died in Paris on 10th of April 1813. So Lagrange was one of the creators of the calculus of variations, deriving the Euler-Lagrange equations for extrema of functionals. So he extended the method to include possible constraints, arriving at the method of Lagrange multipliers. So Lagrange invented the method of solving differential equations known as variation of parameters, applied differential calculus to the theory of probabilities, and worked on solutions for algebraic equations. So he also proved that every natural number is a sum of four squares. His treatise Theorie des Fonctions Analytics laid some of the foundations of group theory, anticipating Galois. In calculus, Lagrange developed a novel approach to interpolation and Taylor series. He studied the three-body problem for the Earth, Sun, and Moon on 1764, and the movement of Jupiter's satellites on 1766, and in 1772 found the special case solutions to this problem that yields what are now known as Lagrangian points. Lagrange is best known for transforming Newtonian mechanics into a branch of analysis. So Lagrangian mechanics and presented the mechanical principles as simple results of the variational calculus.
Pierre Simon Laplace. He was born on March 23, 1749 in Normandy, France, and died on March 5, 1827 in Paris, France. Referred to as the French Newton, he is a mathematician and astronomer, mainly on differential equations and finite differences, mathematical and philosophical concepts of probability and statistics. He developed his own version of the so-called Bayesian interpretation of probability independently of Thomas Bayes. Maintained that there should be a set of scientific laws that would allow us to predict everything about the universe and how it works. Complete science determinism. He also published popular work for general reader, a philosophical essay on probability. This work was the introduction to the second edition of his comprehensive and important analytic theory of probability. André Marie Legendre. He was born on September 18, 1752 in Paris, France, and died on January 10, 1833 in Paris, France. Statistics, number theory, abstract algebra, and mathematical analysis in the late 18th and early 19th centuries. His famous work, Elements of Geometry, a reworking of Euclid's book, became the leading geometry textbook for almost 100 years. Inspired the creation and almost universal adoption of the metric system of measures and weights.
Next is we have Johann Lambert. He is a Swiss mathematician and a prominent astronomer. He is also a son of a tailor. He was largely self-educated, and early in his life began geometric and astronomical investigation by means of instrument that he designed and built himself. So it is clearly stated that the only instrument that Johann Lambert uses in his investigation are only the instruments that he designed and built himself. He provided a rigorous proof in 1761 that pi is irrational, that it cannot be expressed as a fraction of a over b, where a is an integer and b is a non-zero integer. This definitively proved that it would never be possible to measure it or to calculate it accurately, although the obsession with obtaining more and more accurate approximation continues to this day. First, to introduce hyperbolic functions into trigonometry and made some present conjectures regarding non-Euclidean space and the properties of hyperbolic triangles. So next is we have the Bernoullis. The Bernoullis produced half a dozen outstanding mathematicians at the end of the 70th and the start of the 18th century. Family was a prosperous family of traders and scholars from the free city of Basel in Switzerland. So let us all remember that the Bernoullis family have 8 greatest mathematicians, but among the 8 of them, there are only 3 mathematicians who were most famous and outstanding, and they were Jacob Bernoulli, Johann Bernoulli, and Daniel Bernoullis, and they were largely responsible for further developing of Leibniz's infinitesimal calculus, particularly through the generalization and extension of calculus known as the calculus of variations, as well as Pascal's and Fermat's probability and number theory.
Bernoulli brothers. Jacob and Johann Bernoulli flouted their father's wishes to them and began studying mathematics together. Jacob Bernoulli was Nicolaus Bernoulli's oldest son. He was one of the pioneers of the mathematical theory of probability. Johann Bernoulli was Jacob's younger brother. He was a brilliant mathematician who made important discoveries in the field of calculus. They have a jealous and competitive relationship. Bernoullis were as conceited and arrogant as they were brilliant. They engaged in bitter rivalries with one another. Jacob was an appointed professor of Basel University and died from TB. Johann took over Jacob's position. Jacob was very jealous of his brother, and Jacob realized his brother's talents and began to brag about his work and at the same time belittled his brother. Despite family problems, Johann was an excellent mathematician. He studied the theory of differential equations, discovered fundamental principles of mechanics and law of optics. Jacob was Euler's teacher. Johann was a teacher of Guillaume de l'Hôpital. The Bernoulli brothers were the first mathematicians to not only study and understand infinitesimal calculus but to apply it to various problems, designing a sloping ramp which would allow a ball to roll from the top to the bottom in the fastest possible time. Jacob Bernoulli's book was The Art of Conjecture. Jacob Bernoulli also discovered the approximate value of the irrational number e while exploring the compound interest on loans. Johann's sons and even his grandchildren were all accomplished mathematicians and teachers. Daniel Bernoulli in particular is well known for his work on fluid mechanics, especially Bernoulli's principle. The Bernoullis' competitive and combative family relationship is usually said to curtail their collaboration and hold back potential success, which could have happened if they have not been so ruthless to each other. However, perhaps their resentment challenge and inspire each other, resulting in their outstanding mathematical work.
Euler is a Swiss mathematician and is one of the giants of the 18th century mathematics. Like the Bernoulli, he was also born in Basel, Switzerland, and studied in Basel University for a while. He spent most of his academic life in Russia and Germany, especially in the burgeoning St. Petersburg of Peter the Great and Catherine the Great, because he could not find a good position and reputation in his hometown, Switzerland, due to the overwhelming popularity of the Bernoulli family. Euler is considered one of the greatest mathematicians of all time. His interests covered almost all aspects of mathematics, from geometry, calculus, trigonometry, algebra, number theory, optics, astronomy, cartography, mechanics, weights and measures, and even the theory of music. Euler created and popularized mathematical notations. The base of the natural logarithm, the imaginary unit, f of x, sigma, abc or the constants, xyz are the variables or unknown in an equation, sine, cosine, tangent, cotangent, secant and cosecant, the trigonometric functions, and the pi.
came up with many notations, as mentioned earlier. He had an unbelievable mental calculation skills and photographic memory. He also combined several symbols together in an amazing feat of mathematical alchemy to produce one of the most beautiful of all mathematical equations, e raised to the power of I times pi is equal to -1, or the Euler's identity. This equation combines arithmetic, calculus, trigonometry, and complex analysis into what has been called the most remarkable formula in mathematics, uncanny and sublime, and filled with cosmic beauty, or among others. In 1735, Euler solved an intransigent mathematical and logical problem known as the Seven Bridges of Königsberg problem, which has perplexed scholars for many years, and in doing so, laid the foundations of graph theory and presaged the important mathematical idea of topology. In 1766, Euler accepted the invitation from Catherine the Great to return to the St. Petersburg Academy and spent the rest of his life in Russia. However, his second stay in the country was marred by tragedy, including a fire in 1771, which cost him his home and almost his life, and the loss in 1773 of his dear wife of 40 years, Katharina. He later married Katharina's half-sister, Salome Abigail, and this marriage would last until his death from a brain hemorrhage in 1783. In a long run, Euler had a long life and had 13 children. Yet he was blind in his latter years. Initially sealed, Euler's reputation was announced in 1735 and concerned the calculation of infinite sums. It was called the Basel problem after the Bernoullis had tried and failed to solve it.
The demonstration of geometrical properties such as Euler's line and Euler's circle, the definition of the Euler characteristics, or chi for the surfaces polyhedral, a new method for solving quartic equations, the prime number theorem, published 900 books. Proofs and in some cases disproof of some of Fermat's theorem and conjectures, the discovery of over 60 amicable numbers, a method of calculating integrals with complex limits, foreshadowing the development of modern complex analysis, the calculus of variations including its best known, the Euler and Lagrange equation, a proof of the infinitude of primes using the divergence of the harmonic series, the integration of Leibniz differential calculus with Newton's method of fluxions into a form of calculus we would recognize today are just some of the contributions of Euler. So, Euler, or Leonhard Euler, was one of the most eminent mathematicians in the 18th century, and is held to be one of the greatest in history. He is also widely considered to be the most prolific, as his collected works fill 92 volumes, more than anyone else in the field. He spent most of his adult life in St. Petersburg, Russia, and in Berlin, then the capital of Prussia. So, Euler worked in almost all areas of mathematics, such as geometry, infinitesimal calculus, trigonometry, algebra, and number theorem, as well as continuum physics, Leonard theory, and other areas of physics. He is a seminal figure in the history of mathematics, If printed, his works, many of which are of fundamental interest, would occupy between 60 and 80 quarto volumes. Euler's name is associated with a large number of topics. So, Euler linked the nature of prime distribution with ideas in analysis. He proved that the sum of the reciprocals in the primes diverges. So, in doing so, he discovered the connection between the Riemann-Zeta function and the prime numbers. This is known as the Euler product formula for the Riemann-Zeta function. Euler proved Newton's identities, Fermat's little theorem, Fermat's theorem on sums of two squares, and he made distinct contributions to Lagrange's four-square theorem. He also invented the twotiant function, the number of positive integers less than or equal to the integer n that are co-prime to n. Using properties of this function, he generalized Fermat's little theorem to what is now known as Euler's theorem. He contributed significantly to the theory of perfect numbers. So, Euler also introduced the use of the exponential functions and logarithms in analytic proofs. He discovered ways to express various logarithmic functions using power series, and he successfully defined logarithms for negative and complex numbers, thus greatly expanding the scope of mathematical applications of logarithms. He also defined the exponential functions of complex numbers and discovered its relation to the trigonometric functions for any real number. So, Euler elaborated the theory of higher transcendental functions by introducing the gamma function and introduced a new method for solving quartic equations. He found a way to calculate integrals with complex limits, foreshadowing the development of modern complex analysis. He invented the calculus of variations, including its best-known result, the Euler-Lagrange equation. Euler pioneered the use of analytic methods to solve number theory problems. In doing so, he united two disparate branches of mathematics and introduced a new field of study, analytic number theory. In breaking ground for this new field, Euler created the theory of hypergeometric series, Q-series, hyperbolic trigonometric function, and the analytic theory of continued functions. For example, he proved the infinitude of prime using the divergence of the harmonic series, and he used analytic method to gain some of understanding of the way prime numbers are distributed. Euler's work in this area led to the development of the prime number theorem. So, some of Euler's greatest successes were in solving real-world problems analytically, and in some describing numerous applications of the Bernoulli numbers, Fourier series, Euler numbers, the constant in pi, continued fraction, and integrals. He integrated Leibniz's differential calculus with Newton's method of fluxions, and developed tools that made it easier to apply calculus to physical problems. So, he made great strides in improving the numerical approximations of integrals, inventing what are now known as the Euler approximation.
And that's all for today's video, and thank you so much for listening, and I hope that you've learned something from our discussion and you've gained some knowledge, some insights about the mathematics in the 18th century and the mathematicians in 18th century. So thank you. That's all. Keep safe. God bless us all.